All right, guys, let's take a look at geometric sequences now. So very similar to arithmetic. Instead of adding, though, we are multiplying. So a sequence in which the ratio between any two consecutive terms is constant. And we call that term, that ratio, the common ratio represented by the letter R. So R is our common ratio. So if we have 2 times 3, that's 6 times 3, well, that's 18, etc. That's geometric. Instead of adding, we're multiplying. Now we need to determine if these are geometric, and if they are, we're going to identify the common ratio. To get our common ratio, we're going to take our second term divided by our first term. 12 divided by 6, that's 2. Since we're not sure if it's geometric or not, check them all. 24 divided by 12, 2. 48 divided by 24, 2. So yes, this is geometric. And the common ratio is 2. So in the previous video, I had some complaints about the audio cutting out, so I'm trying my AirPods. Let me know if this is any better. Hopefully it's not worse. It also says find the next 3 terms. So 48 times 2, that's 96. 96 times 2, that's 192. And then 192 times 2, 3, 86. Let me times 2, not 3, 1, 384. Let's go ahead and use this thing to make sure I don't screw up basic arithmetic. 48 times 2, 96, 192, 384. There we go. Now this one was geometric, found our common ratio. Again, take the second term divided by the first term. So 270. 1 second, please. Move this bar out of the way. Move this one. 270 divided by 810 is a third. 90 divided by 270 is 1/3. 30 over 90, 3 over 9, 1/3. So yes, this is also geometric. And the common ratio is 1/3. So I can do this one pretty easily. 30 times 1/3 is 10. 10 times 1/3, well, that's 10 thirds. 10 thirds times a third, well, that's 10 ninths. Use your calculator if you don't believe me. Let's check this one out. 10 divided by -2, well, that's -5, right? 10 divided by -2 is -5. And if I do that, 10 times -5, yeah, times -5, still working. So you can check it either way you want to. You can either try multiplying and see if that first common ratio worked, or you can divide each of the consecutive terms. As long as you get the same result, you're good. So -5 for R, this is another yes. And that's -1250. 6,250. And -31,250. Sure, why not? Let's see, if I multiply that by 2, okay, this is not. 4 times 2 is 8, 8 times 2 is not 20, so that's a no right off the bat. Let's see, that's a fourth, that's a fourth, that's a fourth, and it's negative, yes. So cool. This is also geometric. R is -1/4. So dividing by 4 each time or multiplying by -1/4, whichever way you want to look at it. This is going to be powers, but I don't know after 64. Let's see. -1/16 times -1/4. That's going to be 1/64. This next one, negative 1/256. Think. And then 1024, yeah. Just your powers of 2, basically. Anyway, next up, we have 2 times 2 is 4. 4 times 2 is not 16. So this is a big fat no. -7. Yeah, I think that works. That's powers of 7 times 2. So let's double check. -14 times 2. Not 2, 7, sorry. 98 times 7. 686, so -4,802. Again, this is a yes. Our common ratio was 7. And if I multiply 33,614, also negative. And then negative, huge freaking number, 235,298. As long as you have yourself a calculator, you'll be fine. If you don't have your calculator, well, then good luck. Let's see, common ratio, 8 divided by 3.2 is 5/2. Does that work? I can do 20 over 8. That's also 5/2. Or I could do 20 times 5/2. And that should give you the next number, 50. So either way you want to look at it will work. So R is 5/2. The yes. And multiply that by 5/2. I get 125. And then do that again, 625 over 2. And then something over 4. 3,125 over 4. Beautiful. Keep going. So these were all nice and easy, find the next 3 terms, not too terrible. This, of course, is a recursive formula, if you remember from a few weeks ago. That's not so useful if you want to say find a millionth term or whatever. You're not going to do this a million times. At least I hope you won't. You'll probably die first or get it wrong, or both. So instead, anytime we have a geometric sequence, we can use this explicit formula. A sub n is equal to A1 times R to the n minus 1 power. A1 is your first term, and R is the common ratio. Let's try it out. So right rule for each sequence, then find A sub n. Let's see, what are we multiplying by? 5. R is 5. What's A1? A1 is 1. So my rule, A sub n is equal to A1, which is 1, times, let's see, it's R to the n minus 1. R is 5 to the n minus 1. So this will get us any n. This is a 5, not an s. This wants a 6. So we need 2 things. First, we need to find the general explicit formula. Then we need to plug in the number 6. And that 1 times isn't going to do us any good. So 5 to the 5th power is 3,125. Okay, let's see. Cutting this in half, it looks like. R is a half. A1 is 130. So our explicit formula will be AN equals A1 times, just a fraction, I'm going to go ahead and put it in parentheses, R to the n minus 1. We need A6, so let me write it out first and then I'll type it in. And you don't need to do any simplification in your head, you can just type it in a calculator just like this, and it'll perfectly fine pop out the answer for you. If you do simplification in your head, don't screw up. So a half raised to the 6 minus 1 to the 65 over 16. Let's see, I'm not sure. Let me try typing this again. This is the right answer, 65 over 16. But I want to see what happens if I don't put the parentheses. It might still work. I don't know. I really don't. If I put the thing there, that's not going to work. What if I do it right here? I think this will still work. Okay, it still works. So as long as you make sure the whole fraction is being raised to the exponent, you don't have to have the parentheses. I suggest just putting those parentheses anyway to be safe. That way you know it won't screw up. Looks like -4 here. A1 is 2. So AN is 2 times -4 to the n minus 1. On this one, you definitely need parentheses. It's got that negative on there. If you don't put the parentheses, it's only going to raise the 4 to the exponent. And if this is an even number, it should be positive. But if we type an even number without these parentheses, it will be negative. So make sure with those parentheses, negative. Just put them all the time. Just be safe. They don't hurt, so just use them. Two times -4 raised to the 6 minus 1. And we should get -2048. Let's conduct a little experiment here and see if the parentheses are indeed necessary. Let's do something that'll make an even power like 7. So I should get a positive that 8,192. If I drop these parentheses, will I still get the positive? Let's find out. No, I do not. So yep, make sure you put that thing in freaking parentheses, just to be safe. Negatives must be in parentheses. Fractions, you probably want to put them in parentheses. Regular numbers, doesn't hurt to put them in parentheses. Use it in parentheses. Do it. 3 looks like my common ratio here. A1 is 8. So A sub n is equal to 8 times 3 to the n minus 1. A6, which I'm still using A6 because the problem told me to right here in the directions. Find A6. That's the only reason I'm using 6. It also tells me to find this rule, so I have to do this step and this step. Yes, they're both necessary. It won't always be 6. Sometimes you might use 152 million. Who knows? Except that won't work in the calculator, so probably not that. 8 times 3, again, the parentheses don't hurt, raised to the 6 minus 1. Gives us 1,944. Keep it up. Don't see the common ratio off the top of my head, so let me figure it out. 90 divided by 135 is 2/3. Yep, 2/3 works. 2/3, 2/3. Yep, I see it. A1 is 135. And our explicit formula will be AN is equal to 135 times 2/3 raised to the n minus 1 power. Plug in 6. Let's see what we come up with. Put that in there, and we get 160 over 9. That's what the calculator told me. That's what I'm going to put down. I'm not going to question it. Does it make sense? I mean, I'm dividing by 3 repeatedly and multiplying by 2. So yeah, my denominator is multiple 3. Makes sense. Dividing by 4 looks like, yes, indeed. -4, -4. We're starting at -3,200. AN can equal -3,200 times -4 raised to the n minus 1, A6, sorry. -3,200 times -4 to the 6 minus 1. Absolutely must have parentheses on this one. Otherwise, you'll get the answer wrong every other time. Hang on if it's negative or not. Or saying if this is even or not, we'll make this negative. Stay negative. Wow, that's a big number. Okay, write it down. 3,276,000. $800. Okay, why not? All right, so this one's a little different. We want to find A8, but we're given A1 and R. Oh, well, that's easy. We know our formula. AN is equal to A1 times R to the n minus 1. In this case, our n is 8. 8 minus 1 is 7. Who cares? Type in the calculator. Also, the exponent doesn't need parentheses because it is all in the exponent. But if you're using some other calculator, you'll definitely need it. 114,688. Just good habit. Use parentheses. Don't screw up. Now let's look at this one. This time we know what A5 is. We want to find out what A1 is. We know our common ratio. So we could go backwards and just start at A5 and divide and divide and divide. But look at this formula. Well, this formula. Oops. We know A5, and we're looking for A1. So let's just plug in the info we got. A5 is -68. A1, we don't know. R is -0.5. And N, if we're using A5, would be 5. So -68 equals A1 times, type this in the calculator. -0.5 raised to the 5 minus 1. And that gives me 1/16. Multiply both sides by 16. And we get -1,088. equals, those cancel, A1. Since we're looking for A1, we can reverse this formula. That's formula 2, right? Now this one's more interesting. We're not given R. We're given A1 and we're given another another term. We got to think. We're trying to see what factor we're going by, right? We're not adding. We're trying to see what factor. So I need to do, so the difference, I need to do the quotient here. So to get from A1 all the way to A4, I had to multiply by a total of 343. Okay, I recognize that. That's 7 cubed. Now, I did that in how many squares? 4 minus 1 is 3. But instead of dividing by that 3, like we did with the arithmetic sequence, we're going to take the third root of 343, which is indeed 7. Told you. So now we have A1 and we have R. Write our formula. And is equal to 13 times 7 to the n minus 1. That's an n. A3 in this case will be 13 times 7 to 30 minus 1. Use your calculator. 637. Sure. If I multiply this by our 7, that better give me 4,459. Let's double check. Sure enough, it does. Okay. Now this one's even more interesting. We're not given A1, we're given A2 and A5. So the process to start with is the same. We're going to take where we ended up at, 0.048. Okay, divide that by where we started. Let's see what kind of madness we come up with here. One over 125. I recognize that as powers of 5 and 1. Okay. Now, how many spaces did we move? 5 minus 2 is 3. So I'm going to take the cube root of this thing right here. I know. Do you know? It's 1/5. So we know this is R. That's what we are. R is 1/5. We're going to write our formula AN equals 6 times, wait a minute, 6 is A2. So how on earth do we get A1? Well, we divide 6 by our 1/5 because this is A2. Go backwards. Of course, you could just do that from here. But let's get the formula. Let's make it fun. Let's get the formula. 6 divided by 1/5. Yeah. That's the same as multiplying by 5, 30. So A1 equals 6 divided by 1/5 because we went back one space. That's 30. Okay. Now we got our info. Let's get our formula. 30 times 1/5 to the 4. Let's just go ahead and plug it in. I'm really lazy. Minus 1. Now, we should get the exact same thing if we divide wherever this is by a fifth. So we should get 6 over 25. Let's find out. 30 times 1/5 raised to the 4 minus 1. 6 over 25, what do you know? The reason that worked is because this is a 5 and that's a 4, so we just need to go back one space. So it would have been easier to do that from the beginning, but it's fun to get the formula. What if we would have needed a 42 instead? Yeah, and we've probably gotten a decimal in the calculator because that's a lot of dividing. Anyway, next. Word problem. Jackson bought a brand new car for $38,000. If the car depreciates in value by 20% each year, what will the car be worth in 8 years? So something to think about. It's depreciating by 20%. What's our common ratio? It's not going to be the 20%. What's left? I can't hear you. Oh, that's because you're not there. I'm talking to myself. Am I crazy? Yes, I am. I know. It's going to be left with 80%, right? So our common ratio is 80% or just 0.8. Because after the first year, it's going to depreciate by 20%. So let's do the word problem math here real quick. 38,000 times 0.2 gives us that 38,000 minus our answer is 30,400, where we could have done times 0.8 and got 30,400. So basic percentages for you guys. If you're going down by 20%, that means you have 80% of the original. So R is 80.8. Just 8. It's just 0.8. 80%, which is 0.8. A1 is 38,000 or 38,000 for those of you that speak English. Sorry. What will the car be worth in 8 years? So that means N is 8. This is A1. Let's write our formula. 38,000. Maybe I can English a little bit. Times 0.8 raised to the N minus 1. In our case, N will be 8. Lots of 8 here. A8 equals 38,000 times 0.8. The 8 minus 1. Not a slight idea what this will come out to be. And we get $7,969. And 18 cents. Why'd that go away? I don't know. Round this, it's monies, people. Remember, we can use decimals in monies and measurements. This is monies. We're going to measure, go to 2 decimal places for it. Money symbol. Or actually, that's the money symbol. It's only got one thing. Yeah, one thing. Go to, if you want some extra work, just go research this versus this. It's kind of interesting. Anyway, that's it for geometric sequences. Can you guess what's next? Geometric series, that's right. Anyway, get there in a minute. See you.